Welcome to AI Research Weekly, your deep dive into the bleeding edge of artificial intelligence. I'm Nova.
And I'm Onyx. This week, we're seeing the agentic AI wave cresting, not just in terms of capabilities, but a significant pivot towards understanding its profound societal and ethical implications. We're also covering some critical advancements in making these complex, multi-agent systems more robust and auditable, alongside a fascinating new quantum optimization benchmark.
Absolutely, Onyx. The sheer volume of papers on agentic AI continues to grow, and it's no longer just about building agents, but about how they interact with each other, with humans, and what that means for society. We've got a lot to unpack. Let's start with where agents are truly pushing the boundaries of scientific discovery.
Indeed. Two papers caught my eye, both demonstrating impressive strides in applying scalable agentic reasoning to complex scientific domains. First, scalable agentic reasoning for designing biologics targeting intrinsically disordered proteins introduces Struct BioReasoner. This is a multi-agent system specifically designed for autonomous biologics discovery, targeting both structured and, crucially, intrinsically disordered proteins, or IDPs.
IDPs are notoriously hard to drug, right? Their flexibility makes them incredibly difficult to model and target with conventional methods. What's Struct BioReasoner's key innovation here?
The core is a novel tournament-based reasoning framework that allows the system to autonomously navigate the vast design space. It leverages an extensible federated agentic middleware called Academy, coordinating specialized agents on high-performance computing infrastructure. The system integrates domain knowledge with access to literature synthesis, AI-driven structure prediction, molecular simulations, and stability analysis. It's not just generating, it's reasoning about conformational ensembles rather than single rigid structures.
So it's not just brute forcing the problem, but intelligently exploring the solution space with a suite of tools. That's a significant methodological leap for biologics design. What were the tangible results?
For the structured protein DARE-F21, over 50% of the 787 designed and validated candidates outperformed human-designed reference binders from literature in terms of improved in silico binding free energy. Even more impressively, for the IDP NMAT2, Struct BioReasoner identified 3 distinct binding modes from 97,066 binders, including the literature-validated NMAT2 P53 interface. This really showcases its capability for these more challenging targets. The team has also open-sourced their code, prompt templates, and configuration files, which is excellent for reproducibility.
That's a big deal. The prospect of autonomously designing IDP targeting therapeutics on exascale platforms is transformative. But I wonder about the compute cost here. Is this going to be accessible, or is it going to be limited to institutions with massive HPC budgets? And how generalizable is the tournament-based reasoning framework beyond biologics? Those are valid questions, Nova. While the paper highlights HPC infrastructure, the focus is on efficient exploration through distributed computational load, suggesting an optimization angle. And the underlying concept of a tournament to refine and select optimal agentic paths could certainly find analogs in other complex multimodal search problems. Connecting to this, another paper, From Data to Discovery, Agentic AI for Transcriptomics Research, provides a similar vision for automating another core scientific process. This framework uses LLMs as an intelligent reasoning and integration layer to automate transcriptomics data retrieval, expression evaluation, and gene relationship discovery from vast, fragmented public repositories like NCBI's Gene Expression Omnibus. So, Struct BioReasoner for design and this one for data synthesis and hypothesis generation. It really illustrates the breadth of agentic AI's potential in accelerating scientific discovery. The value proposition here is immense, automating what used to be incredibly labor-intensive cross-database analysis.
Exactly. It means faster hypothesis generation, evidence synthesis, and identifying functionally related genes using pathway and ontology resources like gene ontology. Both papers demonstrate how specialized agents, orchestrated by LLMs, can not only streamline but fundamentally advance the speed and scope of scientific understanding.
That's the dream, isn't it? Autonomous scientific discovery. But the flip side of agentic systems, especially LLM-driven ones, has always been their inherent stochasticity and the challenges around reproducibility and auditability. We've seen so many papers struggle with agents hallucinating or just going off script. Is there anything this week that addresses that head-on?
There is, and it's a critical piece of the puzzle for deploying agents in regulated or mission-critical environments. The paper, PyOAgent, a hybrid finite-state framework for deterministic orchestration of LLM agentic workflows, introduces a novel framework to bring perfect reproducibility to LLM agent trajectories.
Perfect reproducibility for LLM agents. That sounds almost contradictory. How do they achieve that?
The core idea is to separate the deterministic finite-state control layer from the stochastic computation that occurs within the LLM nodes. Essentially, the orchestration logic, how agents call tools, pass information, and transition between states, becomes perfectly reproducible under fixed decoding. Stochasticity is confined to the specific outputs of individual LLM calls, but the overall workflow, the sequence of operations, becomes deterministic.
That's a clever architectural separation. So you're not trying to make the LLM itself deterministic, but the process of how it's used within an agentic workflow. What are the practical benefits and performance metrics they report?
It brings single-digit to low double-digit orchestration overhead, which is negligible for most applications. More importantly, it features logarithmic cost fault localization, which is crucial for debugging and auditing complex multi-step processes. They also claim routing accuracy that resists degradation even as the tool catalog grows, which is a common pain point for traditional LLM function calling.
The ability to pinpoint exactly where a workflow deviated or failed and to reproduce that failure is huge for development and deployment, especially in enterprise settings. Think about contact centers or any regulated industry. It makes agentic systems auditable and recoverable. Are they providing specific examples of this?
Yes, the framework supports both cyclic directed graphs for controlled stateful loops with human-in-the-loop steps and event-driven graphs for retrieval-augmented pipelines. This flexibility covers a wide range of practical agentic use cases. This is a foundational step towards making agentic AI reliable enough for real-world high-stakes applications. It addresses a major limitation we've seen with purely reactive, prompt-engineered agentic systems.
I agree. It feels like we're moving from a hack-and-pray approach to agentic design towards a more principled engineering discipline. That's a welcome development. But as agentic AI gets more capable and pervasive, the human-AI interface and its societal consequences become even more pressing. We saw a few papers this week delving into these crucial aspects.
Absolutely. And I think one of the most impactful is why AI harms can't be fixed one identity at a time, what 5,300 incident reports reveal about intersectionality. This paper presents a large-scale analysis of 5,300 incident reports across 1,200 documented AI incidents, demonstrating that harms are intersectional, not siloed by individual identity categories.
This is a critical point. The tendency in AI ethics has often been to consider disparate impact along single axes, race, gender, age. This paper really forces us to confront the complex interplay of these factors. What did they find specifically about harm amplification?
They used a structured rubric and LLM analysis to identify 1,513 harmed subjects and their associated identity categories with 98% accuracy. The findings are stark. Age and political identity appear in documented AI harms at rates comparable to race and gender when considered individually. But the real insight is the amplification. They observed harm amplification of up to 3 times at specific intersections, such as adolescent girls, lower-class people of color, and upper-class political elites.
3 times amplification at specific intersections. That's not a minor adjustment to our risk models. That's a fundamental shift in how we approach AI risk assessment. It means our current assessments, which often focus too narrowly on isolated categories, are simply insufficient.
Precisely. Intersectionality, they argue, must be a core component of AI risk assessment to accurately capture how harms are produced and distributed across social groups. It pushes beyond the checklist approach to fairness. And related to the broader societal impact, A new concept emerged this week that caught my attention: cognitive atrophy.
Cognitive atrophy. That sounds ominous. What does that entail?
It describes a developmental state where the delegation of tasks to agentic AI erodes human cognition and regulatory capacities. It's a theoretical concept introduced in a couple of papers, highlighting a potential negative long-term societal impact as we increasingly integrate AI into decision-making workflows.
That's a chilling thought, but an important one. If we offload too much of our cognitive load or regulatory oversight to AI, do we risk losing those very human skills? This ties into the discussion around human-AI interaction preferences as well. Another paper, Effects of Personality and Opinion Alignment in Human-AI Interaction, studied this.
Indeed, that study, involving 1,000 participants, found that users consistently preferred interacting with AI models that shared their opinions, finding them more trustworthy, competent, warm, and persuasive. This supported an AI similarity attraction hypothesis. What's interesting is that they observed only weak effects of AI personality alignment on user preferences, in contrast to the strong effects of opinion alignment.
So it's less about whether the AI is an introvert or extrovert, and more about whether it agrees with you. That seems intuitive, but also potentially dangerous. If users are more trusting of AIs that echo their opinions, what are the implications for filter bubbles, confirmation bias, or even manipulation?
You're hitting on a crucial point, Nova. This perceived trustworthiness, coupled with opinion alignment, could lead to users accepting AI outputs without critical evaluation, even if those outputs are flawed or biased. This is further illuminated by another paper, Real-Time Group Dynamics with LLM Facilitation, Evidence from a Charity Allocation Task.
I recall that one. The LLM facilitators didn't actually improve group consensus, but participants preferred them and reported higher trust in the process.
Despite participants citing inclusivity as their primary reason for preferring LLM facilitators, neither survey nor transcript-based measures showed improved participation equity. It created an illusion of inclusion. What's more concerning is that these LLM facilitators subtly shifted select charity-level allocations by up to 5.5 percentage points, directly impacting the final charitable payout, even when aggregate agreement metrics remained unchanged.
So they influenced outcomes without actually improving the deliberative process, all while users felt more included and trusted the process more. That's a significant governance risk. It means AI can exert directional influence on collective outcomes while fostering a false sense of satisfaction or fairness. This entire cluster of papers around societal impact highlights the need for far more sophisticated evaluation metrics beyond just performance benchmarks.
It really underscores the complexity of responsible AI deployment, moving beyond just technical prowess to understanding profound socio-technical interactions. Before we move to Industry Watch, I do want to briefly mention the Quantum Optimization Benchmarking Library. While not directly in the agentic AI domain, it's a critical foundational piece. It introduces a systematic, fair, and comparable benchmarking framework for quantum optimization methods.
This is important. Quantum advantage is often discussed, but rigorous, standardized benchmarking is often missing. What are the key features?
It includes 10 model-independent problem classes, specifically designed to be challenging for classical methods, with problem sizes ranging from less than 100 to an order of 100,000 decision variables. They've also released an open-source repository with track records of instances and solutions, facilitating standardized reporting. It's about accelerating the field towards empirically verifiable quantum advantage, providing baselines from both classical and quantum solvers.
That's a necessary step to move quantum optimization out of pure theoretical discussions and into measurable progress. It standardizes the conversation.
Now let's pivot to our Industry Watch segment for this week.
The big news that stood out to me, deeply connected to our earlier discussion on AI harms and regulation, is an algorithmic audit of TikTok. The paper, The DSA's Blind Spot, Algorithmic Audit of Advertising and Minor Profiling on TikTok, reveals a significant loophole in the EU's Digital Services Act.
This audit used sock puppet accounts to simulate minor and adult users and found that TikTok formally complies with Article 28(2) of the DSA, shielding minors from profiled formal advertisements. However, the study found that both disclosed and undisclosed ads still exhibit significant profiling aligned with minor user interests.
And the profiling strength in these undisclosed commercial content streams, things like influencer marketing and brand promotions, was 5 to 8 times stronger for minors than for adult formal advertising. This is happening because the DSA's definition of advertisement is too narrow, effectively excluding influencer and brand promotional content.
Precisely. Minors are still exposed to algorithmically targeted commercial content through the very recommendation mechanisms the DSA intends to constrain. This points to a major definitional gap in the regulation, allowing commercial content to circumvent protections. It clearly demonstrates how real-world deployment of AI, in this case recommendation algorithms, can exploit legal blind spots, creating tangible harm to vulnerable populations despite apparent compliance.
It's a textbook example of how a legal framework, even well-intentioned, can be outpaced by technological reality and subtle algorithmic design choices. It really reinforces the need for intersectional risk assessment and more dynamic regulatory approaches we discussed earlier.
Well, that brings us to the end of another packed episode of AI Research Weekly. This week, the acceleration of agentic AI was undeniable, pushing boundaries in scientific discovery with systems like Struct Bioreasoner and frameworks for transcriptomics.
And the conversation around agentic AI is maturing, moving from just capability to critical issues of robustness, as seen with PioAgent and its societal impact. The deep dive into intersectional harms, the concept of cognitive atrophy, and the nuanced dynamics of human-AI interaction with opinion alignment and the illusion of inclusion are all essential for anyone deploying these systems.
Absolutely. The quantum optimization benchmarking library also marks a significant step for that burgeoning field. Looking ahead, I'll be watching for how these deterministic agentic frameworks evolve, especially their adoption in more sensitive domains. And on the ethics front, expect more sophisticated audits like the TikTok one, shining a light on the practical implications of current regulations.
I'll be keen to see if we get more concrete solutions or mitigations for cognitive atrophy, and how researchers start to bake intersectional risk assessment directly into model development rather than as an afterthought.
That's all for this week. Thank you for joining us.
We'll be back next week with more breakthroughs from the world of AI research. Until then, keep digging into those preprints.